Screw compressor lubrication separation and cooling oil systems. 1. In a screw compressor, oil injection performs many useful functions. However, since oil is undesirable in other parts of the refrigeration system, oil-flooded screws bring with them the need for oil separators. 2. The task of the oil separator is to discharge the oil-gas mixture coming out of the compressor, and bring it against a separator head, where it undergoes a change of direction and a large reduction in speed. 3. Larger oil particles are drawn into the oil pan by gravity. 4. For smaller particles or oil smoke filters are used. 5. The small particles impact the internal fibers of the filter and coalesce into larger oil droplets that can then be more easily collected for return to the low-pressure part of the compressor. Oil pump. The purpose of using the oil pump is 1. Supply oil injection for rotors and shaft seal. 2. To cool the compressor. 3. To lubricate the bearings. 4. To supply oil to the capacity control hydraulic system. There are 3 types of compressor designs when it comes to the use of oil pumps. 1. Design of screw compressors, which need a full-time oil pump for the operation of the compressor. 2. Screw compressor design, which only requires the oil pump to operate for startup. This type of oil pump is the auxiliary oil pump. The oil pump is not running after the compressor starts. 3. Design of screw compressors, which can start the compressor without the auxiliary pump oil, and can use the differential pressure of the oil tank system to other parts of the compressor, without oil pump at all. An oil pump is usually required if the system pressure differential is too small when the compressor is used for boost or low stage applications. The oil separator. 1. The oil must be removed as much as possible before the refrigerant goes to the condenser and evaporator. 2. The oil separator is an essential component of the screw compressor. 3. The oil separator also serves as an oil reservoir. 4. Screw compressor separators of modern design are equipped with coalescing filters. 5. Oil carryover rate can be 3 to 10 ppm depending on operating conditions. 6. Most standard units supplied by manufacturers have a horizontal oil separator. Screw compressor oil refrigeration systems. Since most of the heat of compression is transferred to the oil during compression, an oil cooling system must remove or dissipate this heat. The 3 most common refrigeration systems are 1. Water-cooled. 2. Cooled by Thermosyphon. 3. Liquid injection cooling. Air-cooled oil coolers are also used, but not as popular as the previous 3 systems and will not be covered here. Oil cooling by water. 1. The hot oil leaves the separator, passes through a strainer and reaches the oil pump. 2. The oil is pumped through a shell and tube or plate type heat exchanger, where the heat is rejected to the circulating water or glycol. 3. The cold oil is then filtered and returned to the compressor for re-injection. 4. The disadvantages of this system involve the initial cost and maintenance of the water or glycol system. 5. There are risks of breakage or clogging of tubes by not maintaining the proper condition of the water. 6. The use of glycol in the closed circuit eliminates the risks of contamination. Thermosyphon oil cooling. 1. Thermosyphon oil cooling is the most common method of external oil cooling. 2. The system is similar to the water-cooled system, except that the water is replaced by the same refrigerant in the circuit. 3. This method uses high-pressure liquid refrigerant from the condenser to remove heat from the oil. 4. As the hot oil enters the shell side of the heat exchanger, the liquid refrigerant receives heat from the boiling oil to rise back into the receiver. 5. The steam generated by this process is sent back to the inlet of the condenser where it gives up heat and returns with the liquid from the system. 6. In fact, The operating principle of this exchanger is the same as that of the gravity-flooded evaporator. 7. Thermosyphon systems are popular because they require virtually no maintenance. 8. External oil cooling has a higher initial cost than liquid injection oil cooling discussed below, but the low maintenance costs and increased compressor performance quickly make up for the initial investment. Liquid injection oil cooling 1. The amount of oil and refrigerant are controlled to the desired level by a thermal expansion valve. 2. The expansion valve has a plug installed in the discharge line of the compressor. 3. The discharge temperature value tells you how much cooling the oil needs. 4. Liquid injection cooling is achieved by injecting high-pressure liquid refrigerant into the compressor side port to absorb heat. 5. The liquid is metered by a thermostatic expansion valve, regulated based on the discharge temperature, to maintain it between 110 and 140 degrees Fahrenheit. 6. Some of the liquid refrigerant will evaporate, absorbing the heat of compression, which in turn helps cool the oil. 7. Liquid injection oil cooling is easy and inexpensive to install with minimal risk of complicated operation. 8. However, there is a performance penalty associated with this method of oil cooling. 9. Part of the injected liquid refrigerant expands through the expansion valve, which also produces flash steam. 10. Flash steam, and steam generated from the heat of the oil, must be compressed, adding power consumption, while elevated pressures within the rotors cause further leakage, reducing capacity. 11. Part of the remaining liquid mixes with the oil, and is entrained in the outlet line with the discharge gas. 12. The injected liquid remains in the compressor for less than 0.1 seconds. 13. Since heat transfer takes time, much of the cooling takes place in the discharge line and oil separator. 14. In the oil separator, the liquid refrigerant has time to absorb heat and be evaporated. 15. Also, part of the liquid refrigerant mixed with the oil will leak through the internal clearances of the compressor to the suction. Liquid injection cooling is attractive due to low initial cost and low maintenance. 16. However, the power and capacity penalties make it unattractive for most applications with high compression temperatures.